Hello everyone, and welcome to lesson 2.6, which is on multiplying rational numbers. Now, as we've talked about in previous sections, a rational number is a number that can be written as a fraction. So this lesson is all on multiplying fractions and different types of fractions. To start out, I want to draw your attention to the words that are written in pink in all caps, and it says no common denominators needed. Now, that is important because a lot of times when we're first learning about fractions, we learn to find common denominators so we can add and subtract. And we've talked about that in previous sections. But sometimes people get a little confused and they start trying to apply that common denominator rule to all fractions, and that's not the case. When we are multiplying fractions, we do not have to have common denominators, which is great news for us because the process is much more straightforward. We can just go right to solving. So now we talk about how do we solve and how do we multiply fractions. Well, all we have to do is multiply the numbers straight across the top and then multiply the numbers straight across the bottom. Once we get that answer, we need to check it to see if we can reduce it. If we can't, then we are done. If we can, then we reduce it, and then we're done. So it is a very straightforward process. Let's go ahead and get into our examples here. Getting into our first example, we have 3/4 times 1/8. By following the rules to multiply, all we have to do is multiply across the top and across the bottom. That ends up giving me 3 times 1 and 4 times 8 on the bottom. Multiplying 3 times 1, I get 3. Multiplying 4 times 8, I get 32. And now that I've multiplied across the top and I've multiplied across the bottom, all I have to do is check to see if it can reduce. 3 over 32 cannot reduce. So that is your answer. Moving on to number 2, we see in this case we have a whole number times a fraction. And at first glance, this problem doesn't look like it should be in this section. But what we know is we can rewrite whole numbers by just saying, making it over 1. And now that I have 17 over 1, 17 over 1 is the same thing as just regular old 17. Well, now that I've made the whole number into a fraction, it's the same kind of deal. We're going to multiply across the top. We're going to multiply across the bottom. We end up getting 17 times 4 on top and 1 times 7 on the bottom. That ends up being 68 over 7. Now that I have that answer, I check to see if it can reduce. It cannot. So we have our final answer. Now, I want you to take a look at the answers from parts 1 and 2, from examples 1 and 2. Notice that the answer in example 1 is just a regular fraction. The larger number is in the denominator on the bottom, and that's a normal fraction. That's okay. Now we look at our answer in example 2, and we see that we have our larger number in the numerator on top. That's what's called an improper fraction. That is okay too. We don't have to change anything. You don't have to make it a mixed number. You don't have to make it a decimal. Once you get your answer, if you can't reduce it anymore, you are done. You don't have to do any more. That is actually going to help us later on in the year as we get into some more material. Okay, moving on to example 3. We have negative 3/4 times 5/10. And when we look at this problem, we see the negative, and our eyes are drawn to that negative, and we think, oh no, we have to do something crazy. That's not true. Right? All we have to do is just follow the same rules. We multiply across the top, we multiply across the bottom, and then we reduce. So multiplying across the top, I get negative 3 times 5. Multiplying across the bottom, I get 4 times 10. And then simplifying, I get negative 15 over 40. Now it's time to check to see if the problem can reduce. This one can reduce because I know that 5 can go into both 15 and 40. So 5 goes into 15 3 times, and 5 goes into 40 8 times. So then that gives me a final answer of -3, because the negative is still there, over 8. And that's our final answer. So again, that is the process for all multiplication of fractions. That includes mixed numbers, that includes regular fractions and improper fractions. Now, since we have not talked about mixed numbers here, I do want to go over how to convert a mixed number. Right? A mixed number is basically a whole number and then a fraction. You can see the two examples written below. We have 3 and 4/7. We also have -7 and 5/8. So, to convert a mixed number to an improper fraction, which is going to be our goal. We know how to handle improper fractions when we multiply. To convert, we have to take our bottom number, which is our denominator, and we are going to multiply it times the whole number. Then we are going to take that answer and add it to the numerator, right? So, in our first example, right, we're going to multiply 7 times 3. We're going to take that answer and multiply it times 4. So let's see what happens when we do that. 7 times 3 is 21. We add 4 to it to get 25. Now that we've done the first two steps, the last step says take that answer, our final answer, which we found was 25, and write it over the original denominator, which was 7. So I just write 25 over 7, and now I've officially converted that fraction or mixed number. So again, we do 7 times 3, add 4, that got me to 25. I write it over the original denominator, and I'm done. Okay, now we move on to the second example, which is -7 and 5/8, and we have to convert it. Well, we know that we have to multiply the denominator by the whole number, and then we are going to add that to the numerator. I want to draw your attention to this negative sign. For right now, while we are converting, we are not going to worry about that negative sign. We don't need to get into, oh, hey, it's 8 times -7, then we're going to add we're not going to do any of that, right? Because the negative applies to the entire mixed number. So everything in there is negative. What we are going to end up doing is we're going to deal with that negative at the end. So for right now, we're just going to ignore that negative sign, and we're going to do the same process we did in example number 1. So we know we have 7 times 8, or 8 times 7, which is 56, and then we add 5 to that, which ends up giving me 61. So, as I write that, 61. And then we know that we write that answer over the original denominator, which in this case was 8. Now that we have found that improper fraction, we can go back and add that negative sign in. Because the negative applies to the whole mixed number, so the negative applies to the whole improper fraction. We know that the answer is going to be negative, but that doesn't change what we do. That doesn't change how we add or calculate or go through the process. Just follow the process, and if you see a negative, add a negative at the end. Doing that will give you your final answer. Okay, so the reason that we should know how to find and convert mixed numbers is because sometimes you might be asked to multiply different sets of numbers. Now, I understand that this looks a lot complicated, right? It looks a lot worse than what it actually is, right? If we compare these two examples to the examples we had at the beginning, these definitely look like they're a step up. But in reality, we know how to convert mixed numbers. So all we have to do is convert, then we can multiply. So for our first example, we know that we can convert mixed numbers by multiplying and adding. So our first one is 8 times 3, which is 24. Add 1 to get 25. So that's going to be 25 over 8. We do the same thing here. 7 times 4 is 28, plus 1 is 29, and that is going to be over 7. So now all I've done is taken a second and converted our mixed numbers into improper fractions. When we go to solve these problems now, remember it's just as much as multiplying across the top, so 25 times 29 over 8 times 7. All right, so now that we have done that, all we have to do is multiply across the top. So 25 times 29 is 725. 7 times 8 is 56. And now what we want to check is, hey, can we simplify 725 and 56? Can it reduce? No, it can't. So that is our answer. As weird as it seems, we followed our process. We converted mixed numbers to improper fractions. Then we just multiplied across the top, multiplied across the bottom. And even though we got some crazy numbers, some larger than normal numbers, we're okay. All right, doing the same thing with negative numbers in number 2, right? Remember that we multiply and add. So 6 times 3 is 18, plus 1 is 19. That's 19 over 3. Since it's a negative, we just go ahead and throw that negative sign in. The next mixed number, we multiply and add. So 4 times 10 is 40, plus 3 is 43, and we write that over 4. Again, it's a negative, so we go ahead and throw that negative sign in on the end. We multiply these two, so to multiply them again, we just multiply negative 19 times negative 43, and then on the bottom, we multiply 3 times 4. So now, we just got to figure out what negative 19 times negative 43 is. That's going to be 817. And then on the bottom, we have 3 times 4 is 12. So now it comes to our process of reducing. And what we need to check is, can we simplify 817 and 12? Can they be reduced or divided by the same number, right? So we look at all of our options. We say, hey, can 817 be divided by 12? No, it can't. Can it be divided by a factor of 12, which would be 3 or 4? No, it can't. So, again, as crazy of a time as we have, or as crazy as numbers as we get, as odd as it might look, that's our answer, and that's acceptable. Well, I hope this has helped you guys out in multiplying fractions. And as always, if you have any questions, please let me know.